Welcome to yet another video on Java 8 and related videos. If you are preparing for an interview or if you are learning Java or any other related object-oriented language, this would be very important topic when it comes to software development life cycle, right? So it is one of the important principles which every developer or every person who works in the software industry follows it. Basically, it's I would say it's one of the important principles you have to learn, right? There are different other principles available like dry and other, right? So uh, this is one of the most used and also one of the most frequently asked interview questions. So no matter like you are just learning for your own sake or for your own purpose, or you are attending any interview, this video would give you a quick recap and also a quick explanation and crisp short video on it. So let's look into it. So if you see here, I've given a picture here with each letter. It indicates what exactly that principle is about. Okay. So if you see here, one of the first principle is single responsibility. The second one is open closed. The third one is Liskov substitute, and the fourth one is interface segregation, and the fifth one is dependency inversion. So these all SOLID represent an each independent principle. So we'll look in one by one. So basically, if you just check it out, right? So what exactly this solid principle is about, right? So before we dive into like each one of them, uh, why do we even need to follow this particular principles? Because there is a reason, right? So if you have heard of design patterns, basically why do we require those, right? It's an I mean, we write the code and it runs it, right? But basically what is the purpose of using the design pattern? It's same purpose of solid principles, which help us to maintain your software. You design a software in such a way that it improves and like your time by time, and then it's quite manageable and it is scalable as well, right? So you doesn't need to make your system complex, right? It should be easily modifiable. It should be easily extendable. It should be easily like um, I mean, it should be loosely coupled as well, right? So it should not be like it should be, all the components are very tightly coupled, and you are not able to make the changes. We are making some code changes, another one is getting bricked up, or it is very tightly coupled. So it should be very loosely coupled in that case. So because it gives you a feasibility of making it is reusable, so that anybody can use it. It will be quite stable when it comes to using it. It's quite flexible in making changes or modifying it, right? And mainly like when you're using this solid principles, right, it has a clear goal of your component should be doing a clear cut responsibility what it is given to, and it's basically uh, grows, right? It supports growth purpose, right? If you see, right, any software component what you write, right, it should be easy to maintain and go ahead with making the changes, right? So let's look at the each principles. The very first one is single responsibility principle. So basically, when you're designing any system, right, it should be designed in such a way that it only does a single thing, right? It should have only one purpose, right? It should not do like all these features or all this particular thing in a single thing, right? It will make the system very complex. So it should have only one person purpose to do that particular. It has to be created for that particular purpose. It should be maintained for that particular purpose, and then it should be modified for that particular purpose, right? So it should not be like all the functionalities are added in one single, and then in a dilemma that what should be done in order to make this particular change. So it will year on year, time by time, your design will get complex when you doesn't think about the design aspect of it, right? So there should be only one reason to change it, right? So you should be designed in such a way. So example, if you see McDonald's, if you have gone to McDonald's, the like when you buy the burger or fries, right? So if you see, so each person, if you see, they are assigned a specific task, right? The person who takes the order, they are doing their own job. The person who is actually trying to prepare the burgers, they are each in phase manner, like they are aligned, and then they do their job, right? So ultimately it gives you a final product as a burger or any other what you buy it over from there. So basically they do their own job, and then you get an ultimate product of it, and where you get it in a better and efficient way, right? So they all are intended to do their own job, and like they are doing their own single only purpose which are they are hired for, right? So which so whichever classes, when it comes to software entities, right, we deals with classes, right? So whenever you're designing any classes, right, in such a way, it should be designed in such a way that it does only one thing, and it should not be very complex, and you doesn't need to add any irrelevant code which is not belonging to it, right? So it should be it your class should be simple, clear, and straightforward. Hope you got this particular principle. The second principle is open and closed principle. So basically, if you have heard of the inheritance or abstract and interface class when you're learning Java or any other object and oriented, right, languages, right? So there is a concept where you extend that particular parent class, and then you write that particular your own implementation, right? So basically it's designed on this particular principle. So what exactly this particular open close principle says is that we should be your classes or your component should be designed in such a way that it should be open for extension. That is, it doesn't need to worry about modifying the existing logic if it is written over there. You just straightly have to write your own implementation logic, that there should be very specific, right? So you doesn't touch the existing code, and then you write your own logic in a new code, right, or in a new class. So, and basically you should not modify the existing one. So basically don't touch the parent thing or the superclass, whatever it is, right? So you should be very open in extending it, and then you're writing your own logic. That's the reason. That's where your interface, and then in abstract classes, and then the implementation classes comes in picture, right? Where you have a clear abstract things mentioned over there. You go ahead and implement your own logic, and let's say you wanted to design any other features, or you have to add another features, right? You create you extend that particular feature, you write your own logic over there, right? Liskov principle, that is Liskov substitution. So when it comes to this particular principle, we have the parent and the child class, right? This principle, what it says is that you have if you have heard of that, let's say the parent class and the derived class, right? So any location where we can make use of the parent class, we should be also be able to make use of the derived class as well, because they are all the implementation and the one who is going to extend and other particular features which are there. So it will be quite relevant, and it can be quite easily replaced with the child thing. So it should not have any impact. So if your component is designed in such a way, and if it is following this particular principle, it's quite efficient, and it is following the principle, solid principles, right? Interface segregation. So now when it comes to interface segregation, what exactly it suggests is that the implementation class which is going to implement any of this particular super or the parent classes, right, they should not force to implement certain functionality which they are not relevant to them. Okay, so let's say you have three interface, or let's say where you have a general purpose interface, right? let's say you're taking orders, doing the payments, you're doing the processing of something else, right? Taking the publishing the emails and other stuff in that particular same functional, right? So you're doing a lot of things in a single thing, right? And what you do is that you have created an interface and you're doing everything inside that. But basically, you should be designing your component in such a way that you doesn't force your implementation to do lot of stuff, right? It should not be relevant. So let's say it should be relevant to what it exactly it is requiring to do. So not like it should be doing payment also, it is doing billing also, it is doing any other, taking ordering and other stuff, right? So it should be crisp and clear. So we should design like at the top level, like it should be completely abstract, that you should be you make use of this particular interface, you cover up every single thing inside that, like, create clear scripts, relevant interface only, which a small and the not the general purpose one, the very small and the crisp one, which can be created, and so that the implementation can extend it if it is requiring. Because if what happens is that if you're trying to create one general of them, right, you unnecessarily have to implement all those which are not necessary to you. Unnecessarily you have to implement all those things, right? So it should be focused, it should be clear, instead of writing a general purpose. This principle says that dependency inversion. So basically, this is one of the last principle in the solid principle. So basically, what exactly it does, it says is that if there are high level modules and the low level modules, right, of the parent and the child class, the child should be the parent should not be dependent on the child. So basically, the high level module should not be dependent on the low level modules, right? So basically, it should be completely abstract, independent, right? Completely abstract, right? So we should not be dependent on the implementation. The implementation should be dependent on the complete abstraction, right? So it should decouple the software from the modules, right? So it is quite easy to make the changes in the implementation, so without affecting the another code. So basically, this is all about like solid principles. Hope I was able to explain what is solid principles in a short and crisp video. Thank you for watching.